It's recorded. Very good. So thank you, first of all, very much for the invitation to come today for this workshop. I was listening very carefully yesterday, all the presentations, to try to understand what types of topics, subjects, problems we are discussing. And actually, I came to the conclusion that we are in the workshops of open geospatial science and or decentralized web, because it's not always coming together, because it's actually very difficult to put together the topic of geospatial science, open science, and decentralization. And I believe we don't have many examples that show that. But it's also very exciting field, because maybe we're actually discussing something very new that would change paradigms, to actually introduce a lot of innovation to our traditional systems of working, analyzing, and making data and information services accessible to the end users. So I did provide a title of my presentation, as you requested, in the to have something available in the program. So I called my presentation "Distributed Ledger Technologies for Earth Observation: Use Cases for Data Management and Applications." So what I want to say is that I will talk about some of the projects that I personally managed and implemented at EVA, that looked at distributed ledger or blockchain technologies for EU use cases. But this is not going to be the only topic that I'll be talking about, because I want to actually put any other observations that I had after the first day of this workshop to this presentation as well. And actually, I wanted to start with the question of open science. By referring something that was organized by ESA. I don't know how to take the screen out. No. Okay. Sorry, I don't know how to take it off the screen. But so we organized around a year ago an EO or ESA Science Strategy Workshop that brought together the community of hundreds of researchers and scientists working on ESA projects and working in Europe on broadly understood earth sciences. And we had, thank you. So we had a large number of, actually it was a 2-day workshop. We had a large number of sessions, and one of the splinter sessions was dedicated to open science and digital innovation. And what I brought here was something which was roughly recorded notes from those splinter sessions that actually voiced the type of the requirements on how the community sees open science and digital innovation, what they think should be the priority. And I will not go through all of it, because I think it's very specific to the workshop. I just wanted the workshop that we had in June, but I wanted to refer to some of the points that I think is relevant to what was discussed here in this meeting. And for example, discussing reusable open science algorithms and voicing a requirement for transparency, provenance across the digital value chain, so that we can capture the reference between the data and the products that are being produced from the data. Another question was related, okay, do we have any technological advances that are coming in the next 4 or 5 years that would actually allow to adopt more of an open science approach to EO community? And again, the community voiced that the need for traceability and trust across the digital value chains, very important. Then, okay, another question was, okay, so what can we do in order to not only ensure the, say, the transition from scientific research to operational services, but what kinds of incentives we could, new types of incentives that we could provide to the community. So I don't know exactly what the EUMETSAT incentive is. I suppose that a lot of research teams that are working on scientific projects actually get taken up for the operational service implementation. But actually, to make a point that we need new or different reward systems in the community is actually a very valid point and could be explored through a number of separate projects and approaches. Okay, the scientific community is driven by demonstration of an impact, and the impact has a very specific metrics. And there was a presentation yesterday that really was talking about the fact that scientists are driven mainly by the number of publications that they are putting out there to the community. But maybe we need to work on some kind of new types of metrics. So, for example, the number of collaborators on the activity, or the how active are the collaborators in the communities? Are the products or processes or workflows, are they being reused in a very specific context? And can we trace that? Can we track that? This reusability of data and software. And finally, there was open floor for discussion, and there were members of the community voicing the need for full provenance chain of data products in preparation for the emergence of the AI methods coming online, and probably being quite disruptive for the community. Right, so this is the context that we're working in, and this is why I decided to actually, out of many different things that I could show you today about blockchain and projects that we've done, just focus on data provenance and traceability, because this is a field that directly corresponds to the requirements that were voiced by the science community. And this is a field where we've done a number of technology trials where we actually tested different tools, including decentralized tools. Now, the context for all of this is very well known to everybody. So we are in Europe actually operating the largest data factories, Earth observation data factories in the world, primarily with the Copernicus program, but not only. But not many people know what is coming next in the pipeline, because we have some data being produced by Copernicus program. We are here, and we are ready for 1 petabyte data production per day. And that is because the program is expanding, and we are right now working on, we have 6 families of Sentinels online, but we are heading for 12 families of Sentinel missions to be operated in 2030s. These are called expansion missions, Sentinel expansion missions, and we're also working on the next generation of current missions. And that is, if you reference this is going to be the true data deluge. And from this really comes a really important implication for both open data quality, data veracity, and data provenance. Because if we don't address it now, imagine try to address it in a couple of years from now, when you have such a huge increase in the sheer volume of data being produced. And at the same time, we know that this open data philosophy associated with the Copernicus program make a huge impact on the overall science community, but with open data comes also a inherent risks, because today with AI tools we are talking about deep fake geography. There's a term that was coined a couple of years ago. It was taken up by some newspapers, but I think relatively quickly forgotten, as the news cycle tends to do to different topics. But we know that this is an issue, that the Earth observation imagery, the same way as any other imagery or digital data being put out there, is subject, or could be subject to some manipulation. And we actually run some. Actually, this was kind of a funny student project developed in ESA Philab, where a group of young researchers put up this website. The city does not exist. It was also a trend at the time that many people were showing things that don't exist, not only in the museum, but also in digital space. So yes, this image is completely fake. It's been manipulated, looks like a Sentinel image, but in fact, the city does not exist. So how the end user is supposed to know that with the data that you're looking at is actually true? Usually what happens is that you have credit here, right? Written, oh, this is actually a Sentinel data taken from the Copernicus data space ecosystem, Sentinel Hub. And that's it. You have to believe that what you're looking at is true. Is true. And today we are actually entering maybe time in the information manipulation, when these kinds of verification is becoming increasingly difficult to accomplish. And why is this important for ESA use cases? And this is an example of a use case. Today in Europe, in other something called Common Agriculture Policy, Sentinel data is used operationally to provide subsidy financing to farmers that are performing certain agriculture processes, such as mowing of the grasslands. And this is an example of a dashboard, and this is completely operationally used by Estonian payment agency that is actually replacing all the field checks with satellite data. And today you make a decision about whether or not this farmer owning this field should be getting the payout based on. Almost done. Well, so they're supposed to, so they're getting payouts if they are mowing their grass before the 30th of June, right? So here you have the very beautiful graph of the NVDA goes down, the coherence with the radar satellite, the one image goes up. You can attribute this to the mowing event, and then based on this, you have a fully operational validated system that actually handles multi-million-dollar or euro payments to the farmers. So it's important if the data is true, because the farmer that, for example, does not get a payout is like, but how did you determine if I mowed my grass or not, right? And they say, well, we have this portal, and we take the data from this portal. So you can imagine, if this goes to court, how do you ensure that the data was actually, first of all, sourced from the credible source, but also how was it processed? And can we today demonstrate the processing steps that could be used as evidence in these kinds of circumstances? So that's the problem. We don't have a solution yet, but you can imagine that that's what we'll be facing. So giving these kinds of considerations, we actually understand what are the requirements for Sentinel databases to provide a little bit more of this kind of credibility, not only the regular typical, let's say, quality assurance, but something which is providing new type of added value and maybe accessible to completely openly and to anybody who would like to verify where the data is coming from. So the requirements are for data lineage, and these requirements are supposed to prevent vulnerabilities, so security validation, data tampering, or malicious interference, accidental data corruption, and processing errors. And that is today considered just for this data layer, right? But then we understand, and actually, this is not, let's say, full front and center in the observation community, but you should, in fact, have a full traceability across the entire value chain. And this is a very difficult problem because the value chain is actually quite complicated. So we have, this is typical, let's say it's an ESA approach, but I guess it's also similarly described in here in the US. So we have a data layer, we have a resource layer, and the resource layer is additional not only data resources but also computational resources. We have dedicated platforms, and then at the end of this layer we have the users, so scientific data exploitation, public sector users, industry users, and so on. And there's actors that are, I'm not going to describe it very in details for lack of time, but you can imagine that there's a lot of things happening inside this ecosystem. So people download data to their own computing facilities because they can, data is open, but they are also uploading algorithms, and they are uploading their own data to the cloud facilities, and there's plenty of interactions happening inside this ecosystem. And I actually prefer this diagram because it will bring me to the point of the decentralization. So it's the same process, but described just for thematic exploitation platform. And this thematic exploitation platform sits here, right? So it's already in the third book. layer, and the ecosystem looks like this, right? And so it's pretty decentralized. So if you you have not only multiple data coming from different missions, so this is a coastal erosion problem. Multiple data coming from multiple systems, but you have multiple actors providing multiple resources in order to define the processing pipeline. So you can imagine that this comes with not only, let's say, data proprietary. This is an English word. So data is proprietary, but also know-how is proprietary. And so people are bringing in their IPR, their knowledge, and they are getting also they're providing added value. So they also would like to derive the value from what they provide. And for us, the interesting question was, could we address the resistance of the value-adding community to work in centralized data systems? Because I'm providing, they're thinking along the lines of, we are providing our most treasured assets, which is our intellectual property, to this centralized ecosystem of, or a cloud facility managed by the third party. How can I be sure that my IP is not violated and that I can actually safely conduct these processes, right? So this was in fact the first 5 minutes left. This was so this was the inspiration to actually understand, okay, so where can we have the distributed ledger technologies coming into this process to provide a value to this ecosystem? And this wasn't at the time, I created the slide 5 years ago. This was at the time at the top of the blockchain hype. This is actually a table that is coming from the World Economic Forum, which is pushing blockchain and distributed ledger agenda very strongly. And in fact, if you look at this table, there's a lot of topics that are of interest to the geospatial community, and the community that is actually orchestrating multiple actors across creating value out of digital data. So value drivers, auditability, data security, automation, compliance, ownership. We would like to be actually fostering open science, so increasing transparency among parties, enable data sharing, trust in data, transparency, resiliency, and so on. I'll take 10 more minutes if that's okay. Yeah. Yes. Okay. So based on this, I was actually, putting a framework. Okay, so how could we explore this further? Because if you have such a strong drive for this technology to be adopted and considered a game changer for many digital industries, then we should actually definitely explore it. And I think that's why I was invited to this workshop. Maybe if you Google my name, this pops up. So there is a white paper. This was created in April 19, blockchain and Earth observation. The second paper is actually a result. It's a report from a trial that we run with KSI blockchain. Technology provided by a Estonian company, GuardTime. And we had also run a project which is called Building Trust in Digital Economy, which was supposed to explore blockchain for IP protection in our digital ecosystems. Now, I have a dilemma now because I want to tell you about these projects, but the bottom line is that we considered a blockchain not being suitable for our purposes. Maybe I will skip most of those slides and get to the point to demonstrate and tell you about the technology that we considered as suitable and actually the technologies we implemented for the Copernicus data space ecosystem. And you can take a look at these slides later on. But just in the spirit of exploration, we understand that the potential of the DLT and blockchain as something that provides a trust layer that enables multi-party collaboration, can be used on sort of any types of digital data. It can record transactions, so you can actually link from one process to another, which is quite interesting. Can be providing, it's a technology that provides a capability without exposing confidential information, very important. For example, for the IP protection, and it can provide a permanent record of everything that happens with the data. But this is not a solution for everything. So, for example, it's only good for the use cases where central authority is difficult to establish or not desired. which is actually not the case for most of the EO data ecosystems, and definitely not suitable for organizations that have a public trust functions, such as ESA or a Copernicus program. And if you actually adopt it because you want to, let's say, protect the content of your scientific process, or manage records with restricted access, maybe this is not a suitable technology for open science. Maybe. Okay, so going forward, yes, so we had this, the EO data provenance traceability requirements definition. So we wanted to have the technology to allow us to retrieve product history, verify if the product copy is genuine, enhance trust in processing chains, and certify or notified about important changes in the products that are being distributed to the users. Based on these very high-level examples, very high-level requirements, we implemented this project with KSI blockchain to demonstrate that actually this this tool is providing important innovation in our processes. It was a project that ran for more than 2 years, and it was sufficiently funded to really run to a useful conclusion. And now I can't go through it, but basically KSI blockchain is, let's say, a typical blockchain. When you have the data, you hash the data, you have a proof of registration that in this case is actually being recorded on something called KSI blockchain. This technology was, in fact, it's completely operational. It's an enterprise blockchain. It's completely operationally implemented for the purposes of data authentication in the Estonian government. I can tell you later on how we selected this this company for this trial. The value chain looks like this. In theory, we have actually the full value chain, being so the data is being hashed every time it actually enters the database for something that allows to reveal the provenance of the data. As a user, you can have an access to integrity proofs, which are actually associated with the data product. Okay, let's talk about adoption. I'm finishing here. So first of all, I already revealed the conclusion of this presentation. So we did not ended up adopting this technology, but it actually allowed to stimulate a lot of internal discussion within the ESA technical officers in terms of what kinds of technology you would like to see in Copernicus or Sentinel data ecosystems. So this was actually demonstrating to us that we can have in fact, completely automated, immutable, and machine-readable traceability tools, which is a long-awaited innovation. We defined this kind of traceability service for Copernicus data space ecosystem to be included in our ecosystem as a functionality inside the ecosystem, but it's actually fully centralized technology. And if you go today to dataspace copernicus.eu, you can read about this traceability tool. It is provided by actually quite a well-known cybersecurity company called DGCert. I don't know if you're familiar with it, but the way that you use it is that you go to the browser, you retrieve the name of the package files that contain Sentinel imagery. You go to the traceability service, you would put here product or checksum, so the name of the product or a checksum, and this would reveal to you the origin of the data. And today, the origin of the data with this ecosystem is considered to be the CDSC data platform. So actually not in fact the ESA payload data ground segment, but the third-party service that is being, actually the contract that was awarded to a third-party service to handle the distribution of entire Sentinel data archive. And actually this is not a great example because you can see that the data is stored in one place, but Actually, there are examples where you can see not only CDSC as a storage location, but also is a long-term data archive. I just couldn't find one for the purpose of this presentation. And everything is open source. Everything is OpenAI, so it is open source. It's open on the GitHub, so you can in fact take a look and understand how the path and hashes are being created. But the certification authority is a European Space Agency. The API is open, can be used by anybody, but you will need to get an authorization from ESA to use this API. This is an interesting feature of the service because that receiving an authorization to use the service would allow you to produce additional traces for a higher level data production. Okay, this is an example of a service where you can understand how much data traces are being produced and where. And the most important thing to know about the traceability service is to understand that this is being today implemented only inside the Copernicus data space ecosystem. But the team at ESA Payload Data Ground segment is actually considered extending this traceability service to production services, which are handled completely, let's say, internally at ESA, so level 1, level 2 data. In this case, our service providers, which are, for example, actually for Sentinel-3 data, would receive the authorization to produce hashes on the lower level data products. And that is something that we are considering implementing. It's not yet implemented today. But the interesting proposition that comes from this level of implementation is, can we actually move from product-based traceability to process-based traceability? Right, and what does it mean? Today, we just hash and we only provide traceability services for the data products which are being produced and released through the system. But could this functionality be also extended to processing toolboxes? So can we also certify, for example, the certain toolbox or certain processing algorithm was used to process certain data that is being produced? So can we create the tree that shows these processing steps? We are discussing right now to create a test bed to use this traceability service to or a simulation environment to accommodate a range of traceability experiments that could demonstrate additional functionalities and maybe set up a new types of industry benchmark for other functions that actually could be demonstrated through this type of traceability test bed. So that's the end of my presentation. Thank you.
Thanks, that was really interesting. We're picking up this question of process-based traceability in the Open Scientific System Demonstrator project as well. And I'm wondering how you think differently about processes in the sense of code, so kind of analytical scripts that might, for instance, provide your mowing or plowing indicator versus trying to trace the whole platform, so kind of the underpinning software stack. So this is something that we've heard from some of our partners, you know, for example, okay, so if you are storing the data on an Amazon S3 bucket versus on an HPC system, the way that those systems chunk the data will cause subtle differences that can have an impact at the pixel level. That's much more challenging to do and then trace on than the code level. So yeah, I'm just interested how you guys are thinking about that.
Okay, this is a really, really good question. And I think you're absolutely identifying the right requirements. But I think we are really on the very early stages of defining requirements for all of this. And this is a really new topic, but because we are dealing with operational data distribution infrastructures, the types of requirements and the type of questions that you have to ask and answer have to be very, very practical. And today, the way that we're thinking about this, why go from product-based to process-based is because There's a problem with very simple reproducibility problem. What kinds of cloud correction or atmospheric correction algorithms you use, right? But so many people talk about, there's so many different tools, you can have a completely different results depending on what kind of atmospheric correction toolboxes you're using. That was, for example, identified by the climate change community that is struggling with this type of question. So I think that if we start resolving things which are simple but important and well understood by the community, we can then try to see how else can we scale it, what kinds of other problems, or maybe what kinds of other traceability requirements that might exist for different types of not user communities, but different types of platforms use cases. But I would say that this topic is so complex and not high on the priority. It's high on the priority because it's clearly need, because we have such a huge problem, right? To come up with solutions for data authenticity or provenance provision. But at the same time, to run the Copernicus data space ecosystem, there is many more immediate needs that need to be addressed. So today, the way that we're thinking is to actually start small. Maybe actually even the commitment from the ground segment PDGS, the federal data ground segment team, to open or create a testbed for additional use cases to be defined and then tested inside this ecosystem, could actually reveal a lot of opportunities for how this could be applied in other ecosystems. But I wouldn't go as far to say this is how ESA is going to do it tomorrow, because we are just really at the early stages to explore, okay, we've done this, where can we go next? And really the next levels is, let's try to provide traceability inside the PDGS and then see how we can actually maybe authorize some users, maybe Copernicus services, to continue to provide traceability services on the higher level of data processing. And Copernicus services, for example, atmospheric service, right? And then you authorize very specific users and then see if that provides value to the community, and then see how else you can scale it.
Where should I go to? This was a 20-minute presentation.
For sure.
So I'm curious to understand more about why blockchain failed, or why it wasn't the right approach there, exactly where you're trying to go, and what's going to be profits are. That being said, second question, what is your openness to pilots, to experimentation, to solve some of these problems? Because I see a huge overlap between the tech that's been talked about and the problems that you need to solve. What is the process for bringing someone on board for these levels? Can you answer some of your questions?
You can read about traceability service on the website of the Copernicus data space ecosystem. So I can give you the website. There's a difficulty to test new things, because again, this is not a scientific project. This is a fully operational data infrastructure that the users expect data to be available, and we have to provide something simple, easily integrated in order to provide them the provenance or the traceability information. Okay, so the blockchain project didn't fail because there was a problem with technology. The technology is actually, like hashing technology, is relatively simple, and then it's a question of how do you organize it. I mean, you can organize it as a blockchain data structure. The problem, the issue was really about do we need such a level of decentralization to provide this kind of service? And inside the Copernicus data space, so we didn't need that, right? But it doesn't mean that. So actually, most of the blockchain project failed because you can't build enough ecosystem around the specific functionalities. that blockchain provides. That's also my experience from many projects that we implemented, not only for this type of use cases. But we are indeed open for testing and demonstrating new approaches. There's a group in ESA called PhilUp that is actually right now thinking about re-engaging with the blockchain community and testing different platforms and different solutions. They recently released something called Decentralized EO Manifesto, which, let's say, highlights the framework for the use cases, which is actually very, very high level. So it's good that it's high level because it allows to bring new ideas to the table. But I'm actually become, after working on this 5 years, I become a big skeptic whether or not this is such a revolutionary technology, because if you don't change how the ecosystem operates, and if there's so much value in centralizing certain processes, this technology is simply not fit for purpose for us.
But I think some of the IPFS related stuff is yet and offers a similar set of problems.
We tested IPFS in another project about 4 years ago, also for EO data hosting, and was not providing additional added value to our processes. I wasn't a technical officer for that project, but my colleague was, and we've done really a lot of due diligence to understand the technology and define the use case. I guess the results from these projects are openly available, and I could take an effort to find it for you. But again, no groundbreaking capabilities. The Earth observation data is should sit close to processing capability. Yeah, not the distribution doesn't provide for us a lot of added value.
Thank you.
I have one. So for the process-based traceability stuff, you move towards that direction, you see an opportunity to potentially store fewer different products. So if you can point to how to create them, then you no longer have to have them readily available if they're not used very much. Of course, makes sense.
Or that would be if even product-based, process-based traceability would result in optimization of Sentinel data hosting, that would be a huge achievement. And we actually need to be open to this because we are all moving towards operating in more green way, right? More efficient from the energy consumption point of view. And imagine a situation when in 5-7 years, when we launch Sentinel expansion missions, and still the community wants to host all the data out there. They're going to grow in a way which would be maybe not very productive from the point of view of how we could orchestrate the data access. But I think we are at the very early stages of thinking about that. But perhaps this implementation of this tool would allow us to actually, for the first time, say, okay, we actually haven't had a tool, and we have an idea how we could do it better, and then see how the not only the community, but also the owners of the program would react to this kind of implementation. Copernicus data space ecosystem in the current framework is a project that will run for between 4 and 6 years. So at the end of this decade, we will have another iteration of this platform. Maybe it will be a little bit more federated or a little bit more distributed. This is yet to be seen, and based on how the usability of this platform and this traceability also actually yield results.
Any other questions? All right. Thank you very much, Anna. Thanks.